So I was trying to solve for the best weapon in the game, but I had to work with an extremely difficult equation, f of x equals x to the 4th power minus 5. This equation models the Hyperion versus the aspect of the Jerry, and depending on its roots, that is the x values where f of x equals 0, I would be able to figure out which weapon is better. I had a great idea where I would show you all how to solve this polynomial expression, since it's really hard, and I thought it could be a great teachable moment. Now the first step to solve this polynomial is going to be to set x to the 4th power minus 5 equal to 0. This is because we want to find the values of x where f of x equals 0. The second step in solving this equation will be to solve this equation. When we solve this equation, we get x equals the 4th root of 5. Now that we have the solution of this equation, we can keep solving this equation. Let S be the set of all solutions to this equation, where S is the set of alpha and k such that f of alpha equals 0, where k is the splitting field of f. By the fundamental theorem of algebra, we know that f will have 4 roots in C, so we can adjoin the 4th root of 5 and I to Q and obtain k equals this thing. So this thing is the field extension of Q which splits f. Since the minimal polynomial p of x with rational coefficients for which the 4th root of 5 is a root is p of x equals x to the 4th minus 5, which is a polynomial of degree 4, then the degree of this thing over Q will be 4. And since the minimal polynomial Q of x with rational coefficients with I 0 is Q of x equals x squared plus 1, which is of degree 2, we have the degree of this thing over Q equals 2. So the order of the Galois group will equal the degree of this thing over Q, which as we just saw is 4 times 2 equals 8. And the Galois group will be generated by an element of order 4 and an element of order 2 because of some weird isomorphisms. We can define the automorphism sigma on K, where sigma maps the 4th root of 5 to I times the 4th root of 5 and fixes all other elements. We can also identify the automorphism tau on K, where tau is the complex conjugation operator. Since sigma and tau are in the Galois group, all compositions of sigma and tau are elements of the Galois group of f as well. We are now ready to solve for the roots of f. Using the roots of f, we know that the 4th root of 5 is a root of f. Since sigma and tau are in the Galois group, we know that they'll give rise to a permutation of the set of roots of f. We can apply the automorphism sigma to find that I times the 4th root of 5 is a root of f. We can apply the automorphism tau to find that negative I times the 4th root of 5 is a root of f. And we can finally apply the automorphism sigma again to find that negative of the 4th root of 5 is a root of f. Since we are dealing with Skyblock, we only actually care about non-negative real valued roots. So we only care about the 4th root of 5 as a solution to this problem. For anyone out there who's actually taking classes on the stuff I'm talking about or has taken them, yeah, I have no idea what I'm talking about, honestly. The idea for this video was to take math terms that I know exist and apply them in a way that I think is probably correct, even if I don't understand it, and give a really overcomplicated way of solving a simple problem, because I think that's the kind of April Fool's video my community expected from me. However, I have not taken a class on any of this. I've done a little reading, not a lot. So if something sounded like gibberish and you've taken you understand this stuff, it probably was. I think I'll come back to this video in a year or two when I have taken algebra classes and be like, wow, here's what I got right, here's what I got wrong, look how stupid I was, and it'll be funny or something. But until then, thank you for putting up with my stupidity, and I hope you have a good rest of your day.